All right, good afternoon, everybody. Resh Mahaber signing in again. I want to talk about what seems to be the doom of everyone's existence with mathematics, and it is word problems. And everyone is unhappy about these. I have yet to figure out why. So I'm going to point something out to you. When you were in grade school, right, and you first started learning reading, there was a class you took right after reading. Anybody remember what it is? And you're probably thinking to yourself, well, what's that class? But it was an instrumental. And I know this is when you remember this is the time when you never really had multiple classes. You had one class and you stayed in that one class, and it was just like a time period kind of a thing. You did reading and then reading comprehension right afterwards. Solving a math problem is cake. Easy. The hardest part with mathematics will always be trying to understand what they're asking for, what they're doing, what you're given, where you're trying to go. Those are the hard ones, okay? So, it's not, if you ever struggled at this, it's not that you suck at math. Let me change your entire mentality behind this. And I struggle with this too, and I can honestly say it wasn't that I sucked at math, it's because I sucked at English, okay? So, what I've done is the best way to do this is we need to look at some stuff that's really not cute to actually get to the bottom of this. And I'm just going to say that note that your vocabulary in the third grade was different than your vocabulary now. What does that mean? That means that later your vocabulary could be increased, which means the word problems could possibly get harder because what you're expected to know and what you actually know are two different things, okay? And it's all about submerging yourself. So how do you get out of this? You do tons of problems. So here we go. These problems are being provided by webassign, which is the online book we use for our course at Wayne State University, okay? And I'm not going to do every one of these. We'll probably only have time to do 2 or 3, but I think it's worth talking about, okay? If you notice, some of these are icky, some of these are not. I'm going to do some easy ones, and we'll do some hard ones. And are they all like, if you notice, a lot of the stuff is perimeter and dimension and no, I want to do number 5. That's good one. Paintings and motorists, so distance, rate, and time. And we got multiple things going on, and this is a really good one. This fishing boat one, current and water and plywood boxes and 3 dimensional. Like, there's a lot of stuff to do with word problems. So if you think about it, you can know all the math in the world, but have a terrible vocabulary and terrible understanding of what words mean, and you will not be able to apply it to anything in the real world. Hence, making the mathematics you know useless. Okay, so let's try to familiarize yourself, and I will tackle these one at a time, and I'm gonna try to see if this thing will let me cut and paste stuff. I don't know. All right. And I find this to be easier. People know how to let me copy. It looks like it might. People know how to. Oh, look at that! It did it. Okay, so people know how to solve word problems, solve mathematical problems. Okay, but here's what I'm going to encourage you guys to do. Okay, don't fret as much with the word problems, but by solving them, try to set them up. If you set them up, the solving part comes in as long as you have the correct setup. So let's read and comprehend. Now, note when you guys read textbooks or not books for novel reading, my wife's a big proprietor. She will read a 400-page book in a couple hours, but can't tell me what's going on in chapter 2. It's because she's programmed to skim. It's not that she's a bad reader. That same book would take me 6 months, but I'll be able to tell you what happened in chapter, page, paragraph, sentence. It's a different kind of reading you have to program yourself to do. So this is critical reading. So that basically means there's no context clues. You don't go any further without knowing what you've read. So it says a square plot of land. Everybody know what a square plot of land looks like? Well, I don't know. It probably looks like a square. So I will try my hardest to draw a square. And since this is like, what's this thing called? Microsoft, it'll probably let me insert a shape, I hope. Insert space. That doesn't help. Insert. It's not helpful. Draw. Maybe I can draw and put something in here. Oh, look. It has rectangles. Maybe you could put a... Oop, it didn't do it. It must not like me. Alright, so I'm not going to waste your guys' time while I'm trying to figure out how my life works. So, here we go. I'm going to draw a Oh, now it wants to do stuff. Let's do this. Sorry, guys. Give me 1 second. Okay. Here's a square plot of land. Okay, so think about you're looking above, looking down on this. A square plot of land has a building that's 60 feet long. So it has a building on it. 60 feet long and 50 feet wide. Now, people are eager to start drawing. Like, I could have started drawing when I said it has a building and drew it right here in the center. But if I would have did that, then I would have missed this thing at the end that says one corner. So the building's not located there. Okay, so this thing is 60 feet long by 50 feet wide. And notice I drew it so one side looked bigger. Okay, you want your drawings to be as accurate to scale as possible. Okay, so this is where my building lives. Okay, my building lives here. Okay, it says the rest of the land outside forms a parking lot. Like, how many times have you driven to a Best Buy and this is the case? Okay, this is all parking lot here. Okay, if the parking lot has an area, so this thing in here, the area is 11400. Okay, so 11,400 square feet. It's a pretty big. No, it's an okay parking lot. They're asking you a question. What is the dimensions of the entire plot of land? So what are they asking you for? Number one, what is the question? They're asking you what is this and what is this? And note they said that is a square plot from the beginning. So whatever this is, this better be the same thing. I haven't even done any math yet. I just put pieces of the puzzle together. So I know what they gave me. That's number one. I know where I'm trying to go. That's number two. Putting it together should be fairly simple. They mentioned area. Does anybody know what the area of anything that looks square-like or rectangular-like is? Yes. So I need to figure out what x is, basically, is the question. Okay, so now let's try to solve this guy. Well, I know this, that area of anything that is rectangular-like is going to be the base side times, books are weird because they give you base and length and width, right? So is going to be the length side times the width side. Okay? So what does this mean? That the length side, I'm going to call that x. And then the width side, I'm going to call this other thing x. Done. But then what's the area? The area is the total shindig of the entire building and parking lot. Like, you had to make that connection. Is there a possible way for me to find the entire area? I think so. They gave me this is 11,400. Do I know what this is? Yeah, I can figure out the area of that. That's not that hard. 60 times 50 is 3,000. So this is just 3,000. So the total area of this should be fairly simple. You're just going to add two things together, this thing and this thing, to get the entire thing. So when you do that, the entire area, the total area, the number that should go here should be 1440. Not a hard word problem, not a hard setup. Can we solve this? Yes, it takes seconds. But the setup is what takes the time. So take your time here until you get 100% acclimated. Okay, now can we solve this? Guys, do not go for a calculator. I know a lot of you are probably thinking, I could square root this, get plus or minus, right? And then I'm going directly for a calculator. Stay away from the calculator. It rots your brain out. So watch what I do here, okay? So I'm not going to put a plus or minus here, even though I should. I'm going to drop the minus sign. Why? Because this is a building. How can it be a negative side? It makes no sense, right? So you still got to be logical with your answers. 14,400. So notice that 14,400 is 144 times 100. Now, why did I do that? Because you should know that I can split this up. Now, this is more work than I would normally show. This is 12. This is 10. So this is 120. Doing these little exercises during these problems is what makes you good at mental math. So please do them as much as possible. So what is your moral of the story? You could say this is 120 feet by 120 feet. Done and done. There's your answer. Not a very, very hard problem. Not a very, very hard setup. Okay? But you got to get an understanding. I would encourage you, and as I work through these problems, I would encourage you to go back to the video when I get done with this. Don't take notes now, but wait until I get done with the video. Go back, relook at it, pause it, work it out yourself, and then come back and then look at the work and see if it matches up. You'll get the most out of the video. All right, let's push on. Let me see if I can cut and paste another one. Let's see another good one to do. That one's easy. This one's kind of the same thing. Let's look at this one. They drew you some garden stuff here. I don't think you need it, though. I'm just going to cut and paste this. Okay, and let's see if it'll let me do it again. Okay, beautiful. All right, so it says a farmer has a rectangular plot of land. Okay, looks great. Okay, so here's a farmer. Here's his rectangular plot of land. I need you to imagine a farmer and his rectangular plot of land. Or, oh, hold on a second here. A farmer has a rectangular garden plot. Yeah, there you go. It's a garden. Be careful. Surrounded by 200 feet of fence. So let me ask you a question. 200 feet of fence. I'm going to draw the fence in highlighted yellow. That's here, because I'm going to plot it in my entire land. Here, here, and here. So I want you to put some common sense together. They said this, and this is actually a word, but I'm not going to say the word, try not to say the word. But he's talking about the entire outsides. If you add all the entire outsides, because you have to circle that entire thing with 200 feet of fence, then what are we talking about here? And I'm not a man for formulas. There's a particular word that you have to have in your tool bank, and that is perimeter. So they're basically talking about the perimeter of this area without actually saying the word perimeter, which is awesome, right? So if you add the entire outside, which is what perimeter is, it's the sum of all measures. Exterior measures? Sum of the sides. Let's keep it simple. Sides. Okay? And now he's going to add some, but how do I write this? Because I have nothing here. So this is what's going to take some creativity. I'm just going to call this something. Let's call this X. X. Some of you now will call it X, but what should I probably call it? Length and width. Why? Because that's what it looks like to me, length and width. So they tell me that the perimeter, so this is in my tool bag, okay? This is in my brain. Okay, so now let's talk about the problem. So they're telling me that this altogether is 200. So I know if I had L plus W plus W, I get 200, which is great, which gives me 2L plus 2W. That looks like a familiar equation, but I went into mathematics because there was no memorization, none. And I know that sounds weird, but I refuse to memorize any formula, any equation, because that means you're not getting an understanding. Okay? So if you notice here, 2L plus 2W, that is the general equation of a perimeter of a rectangle. But you can get the equation of any perimeter just by adding all the sides together. So those conceptual things make memorizing less, understanding better, and overall just makes your experience better. So if you notice here, I did something that was cute. I noticed that 2 went into everything, so I divided by 200. And you'll notice this. Smaller numbers means easier work later on. Because just imagine having to square 200, as opposed to squaring 100. It's a different kind of shindig. So here we go. Let's go ahead and keep pushing through this. Oh, I zoomed down too far. Okay, so I only made it through the first sentence. I ain't made it through everything. Now what do you want me to find? They want me to find the length and the width. So good thing I named it length and width. Good deal. If the area, all right, so now do you know what the area of a rectangle is? The area, and I'm not even going to finish the sentence, is length times width. For my picture, I call this L, I call this W. And in the problem, they said if the area is 2275. All right, so now, here we go. Magic pieces, magic school bus. They give us this. They give us this. What do? Obviously, it's a system of equations. The thing that should come to mind is substitute or eliminate. Obviously, elimination is a no-go in this case. Why? Because you have different things. This is an LW. This is an L, and that's a W, so we can't eliminate these. So what do we need to do? So I'm going to solve for one, plug it in the other one. L is 100 minus W, and then I'm going to shove it right in there. So I get 2275 equals 100 minus W times W. U. All right, now let's get to multiplying. Here we go. This gives me 100W minus W squared. And then, you see how this is a W squared is a negative? It's easier to factor or use quadratic formula if that leading degree is not negative. So I'm going to move everything to the left. So I'm going to subtract it over, or add it over, depending on how you look at it. Same difference, though. 100W. Oops. My handwriting's getting sloppier. W plus 2275 equals 0. All right. So here are your options. You either quadratic this guy, or you factor this guy. Now me, I'm a fan of factoring everything. I am. I can't deal with the numbers, but we have to figure out two factors in here that multiply together. So quadratic might be a thing. And I'm not trying to take up too much time on factoring this because I'm sure that you guys can either factor it or quadratic formula it. And there is something cool called a factor tree that you've been doing since the 3rd grade, which I do for everything now, right? It takes a little bit of basic multiplication for you to get, well, maybe I'll show you a little bit of it. and I'll show you the general strategy, and then you can decide whether or not it's a route you want to go. So if you look at 2275, that's big. Okay, that's huge to figure out what goes in there. So let's see if I could break it down pretty simply. Okay. Well, check this out. I can tell, like, if I had $22.75, I know quarters would go in there pretty nice and nice and easy, right? So how many quarters? So I always try to look at things on how I see the money, the numbers in everyday life. This is money. I could tell you that, what is that? 3 quarters, and then you get another from 22 bucks. How many quarters is that? That's 10 bucks is 40, so that's 80. 88 and 3 more. What's 88 and 3 more? I can't count today. Whew. 91. So that's 91 and 25. Crazy, isn't it? Okay. Notice these two aren't going to give me that. Might need to split this up some more. So that means he needs more factors. Well, I know 91. That's 17 and 3, I think. No. It's 13 and 7. That's what it is. So it's 13 and 7. Ew. But you guys kind of get the idea of how this whole factor tree works. These factors, and I'm going to push, like, I can put this factor with that guy, and it'll give me something that I might need. Make sure I didn't make any copiers. You know, it's all the same. All right. So bottom line is, guys, we're probably going to have to quadratic formula this guy. He's not going to factor out nicely. But I gave you the gist behind it. I'm not going to finish it. I'm going to let you guys do that because I want to talk about one more problem. This is probably my favorite problem of all. All right, so that's an easy polynomial to figure out. If you look at the last video, if you don't know how to do quadratic formula, it'll be discussed in the last video that I just posted. All right, so let's talk about the big kahuna. Which one's the big kahuna? That's this one. I think it's this one. And I'm not going to take the picture down there with us. I'm just going to take the words. Because I feel like the words, in reality, real life doesn't permit us pictures. They don't. People describe to us in words what they want. We have to draw the pictures and figure out what it is. So if you're going to be an engineer, computer scientist, understanding someone's vision doesn't come from that person. Well, it does, but the understanding, they can talk it out and they can draw you diagrams all day, but you have to draw your own diagram to get your own understanding. So I really don't believe in taking someone else's diagram. I want to draw it for myself. All right, so here we go. It says Ali paints in watercolors on a sheet of paper that's 20 by 15. Let me draw my sheet of paper. Boop, boop. This is 15. That's 20. So that's a pretty big piece of paper. I scoot down too much. Okay. Okay. Then it says, hi. Then he places this sheet on a mat so that the uniform wide strip of mat shows around the picture. So what does this mean? All right, guys, I'm going to draw this mat for you so you know. Okay. If you've ever seen a border on like a poster or something, it's always the same all the way around. Unless you go to IKEA, then it seems like everything is different there. But this is the same width all the way around. That's what they mean by uniform strip or uniform width around. They say the perimeter of the mat, so now we're talking about the red shape, is 110. Okay, so they're telling you the perimeter of mat. Notice I use a subscript here of mat to make my life a little bit better. Is 110. So if I add all these sides together, 110. Now here's the question: how wide is the uniform? How wide is the strip of the mat showing around the picture? So let's read this again because that wasn't really too clear. How wide is the strip of the mat showing around the picture? So they're not asking for how wide the mat is. They're looking for how wide the strip is. If I can get this to write out. They're looking for this. And notice that's uniform all the way around. So this is what we're going to do. Let x equal the width of strip. So it doesn't really look like they gave us too much, did they? All right, well, let's put the pieces of the puzzle together. So what do we know? We know the perimeter is 110. Well, perimeter means to add this side, that side, that side, and that side. So let's just pick a side. I'm going to start with this one. What do we know about this side? We don't know anything about the side except for this is x, because we called it x. This is 15. What does this have to be? It's uniform. It's the same, so that's got to be x as well. So what does this side have to be? Well, it has to be x plus 15 plus x. So this is 2x plus 15. Not too bad. That means this is also 2x plus 15 because it is rectangular. So also on this side, check this out. We can use the same kind of conundrum here to get us through. From here to here is 20. That's x, and that's x. So this side's 2x plus 20 and 2x plus 20. That's one of the things I do love about mathematics, though, is like dominoes. Once you start setting it up and ideas come together, you just apply it to something else and it flies through it. All right, so now if we add all the side together, we get 110. So 2x, 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 and 2x gives me 8x. And then 15 and 15 is 30. 20 and 20 is 40. So that is 70 is 110. Can we solve this? See how easy that problem is? This is rinky-dink. In the grand scheme of things. Like if you look at just the work, it is so basic, but it's the understanding that is really required. Okay, understanding that's really required. All right, the video's at 20 minutes, guys, but I really would like to do one more, and I'll just do the setup. I won't do the solve, but I feel like the setup is very, very important on this one. Let's scroll down, and this is the big one I wanted to talk about. We might need our picture here too, but I'll draw it in a diagram. Okay, so it says, and I'm going to draw the picture that they had. They had this, and this, and this. And they said, make sure I got all the details. That's 25 in between. So this is 25 miles. So this is a distance. It says 2 fishing boats depart at a harbor at the same time. So if they're moving, guys, you got to know that distance equals rate times time for each boat. Okay, so they're each going to have their own thing. And since they're both running at the same time, now whatever this guy's time is going to be the same thing this guy's time is. Okay, they haven't identified what the differences in the boats are, so I'm not going to write anything. One traveling east, and one traveling south. So this is the southbound boat. This is the eastbound boat. They both left with the same time. I don't know how fast they're going, and I don't know what distance yet because they're still moving. Okay, so check this out. The eastbound boat, travels at a speed 1 mile an hour faster than the southbound boat. So let's call his rate, if the southbound boat is slower, let's call his rate R. Okay, note this is a distance. This is a distance, so let's be careful here. His rate is just R. Don't know what it is, but I know this guy's rate is R plus 1. All right. It says after 5 hours. So now that if the time is the same, that means the time here is 5, and the time here has to be 5. Okay. The boats are 25 miles apart. So this is the boat. So this is what the 25 miles means, is that this boat moved to a certain distance, this boat moved to a certain distance, and then that means the distance in between is 25 miles. Makes good sense. Okay. Find the speed of the southbound boat. So we just need to figure out the rate of the southbound boat. So how do we put this together? Now you can't blend stuff up, okay guys? So here's something to keep in mind. Physical measures are physical measures. You can only compare rates to rates and distances to distances. They gave us rates and times, and they gave us a distance here. So we need to transform this stuff into rates and times. We know distance equals rate times time. So this is what I'm going to do. I'm going to call the distance this guy moved D1, and I'm going to call the southbound boat D2. And I know this for sure. D1 squared plus D2 squared better be 25 squared. Why so? Pythagorean theorem. Gotta know that. And that's kind of the idea behind knowing that things are moving southbound and eastbound, is that they're moving perpendicular to each other. So you gotta know stuff like that. Otherwise, this problem's a no-go. So now what do? We know distance equals rate times time. So that means that D1 has got to be R plus 1 times 5. And D2 has got to be 5 times R as well. So what does that mean? Now, this means this. Boom. This means this. Boom. And then you just got to grind through the math. That's the easy part. But understanding the setup is the hard part. Now, note, how did I know I needed to do this? Because I needed to compare the distances. Because this is a distance. So I needed to make this a distance and this a distance. And they didn't give me those distances, but they did give me rate and times, which means I can make it into an equation around distance. So let's see if I could do some math here real quick. 5 plus... Oh, no, wait. We got some cool stuff here. It's multiplication, so I'm not going to mess my stuff up. Here we go. We end up getting 25. this will be r plus 1 squared plus 25r equals, what's 25 times 25, guys? Well, 25 times 5 is 125, so that's got to be 625. Yes. All right, so now let's move. And I'm always going to make sure to check your multiplication, because if that's not right, nothing's right. I'm moving on to, it's almost 25 minutes within the video, guys. So I'm probably going to cut you guys short. Just remember that the rate better be positive. Can't really have a negative rate. We're not talking velocity. We're talking rate here. Okay. So work through it. Once again, guys, word problems, the bane of all existence. Just imagine being an engineer and someone says, "Build me a bridge." They don't even tell you what the rates of anything is. They just say, "Build me a bridge," and you have to take everything into account. Screw up there, you lost your engineering license. So it's a lot. It's a big thing that's going to always take working time. So that's why we're in the positions we are to become and get these degrees that we're after. So remember, to do something you've never done, you're going to have to go somewhere. Well, yeah, you're going to have to go somewhere and do some things you've probably never did. So step up, push hard, and I will see you guys on the flip side on the next video. Okay. Next thing to come is going to be solving nonlinear inequalities. So stay tuned. Bye-bye.